What's the overall differentiation rule we're going to need to use? What is it? Product rule. You have f of x equals, quiet kids, x times 2x minus 3 to the 1/2. You have to use the product rule. So f prime of x is going to be equal to the derivative of the first times the second plus the first times the derivative of the second. To the what power? Minus 1/2, but then what goes on the outside? 2, because it's the derivative of the inside. What cancels with that 2? The 1/2. So what are you left with? You're left with f prime of x is equal to 2x minus 3 to the 1/2 plus x over the square root of 2x minus 3. Correct. That's why it's in the denominator. When you raise something to the negative 1/2, it means it's 1 over the square root of that thing.
How did you get, why is,
And that was, use the product rule right here. So we know what the first part is, which is product rule. After using the product rule, it's a matter of simplifying and adding fractions. That's it. Adding fractions, that's it. Right, okay, so here's the question. Okay, here's the equation, everybody. I can show you why this is the biggest reason people get it wrong. If y is equal to this, what's y prime? 2 times 1/2 times x to the first, which is also known as
x.
x. So we know that y prime is equal to x. You're trying to find when is y prime equal to 1/2? When x is equal to?
1/2.
Yes. So y prime equals 1/2 when x is equal to 1/2. They're asking for the point. The point, right? If you have the x value, how do you get the y value? By far, the most common reason people will get this wrong is that they'll do the derivative and then like make something else up because it's like so straightforward. You don't have to do anything. You're answering this question. If y prime is equal to x, when does y prime equal 1/2? When x is equal to 1/2. There's actually no math involved other than the logic, which in itself is math, so it's just a very little amount. It's hard because it's literally right here. You're blinded by the fact that the derivative is just x.
For some reason, I solved for x.
Derivative is wicked straightforward. It's going to be 2x plus 2y. Y prime is equal to what?
-0.
To 0. It's equal to 0. The derivative of a constant is
0.
divide by x. You get x plus y. Y prime is equal to 0. So y prime is equal to negative x over y. We have the first derivative, but we want the second derivative. What rule do we have to use to differentiate this? Quotient rule. Overall, though, what kind of differentiation are we doing? Implicit, because the derivative is in terms of x and y. So this is the quotient rule with implicit differentiation. So we do y double prime is equal to low d high minus high d low, all over what?
Wait, isn't it negative 1?
High d low. Oh, did I just reverse that? Yeah, sorry. High. Sorry.
No.
I did it wrong. Sorry.
Low d high.
It's low d high, but I mean.
I did. Why you guys?
No, I'm asking you if it should be negative 1.
It is. Low d high minus high d low. Sorry. Thank
Why
you.
is it over something?
Over low squared.
Oh, over low
Good.
squared.
Yeah, over low squared. So we simplify this. You get y double prime is equal to negative y plus xy prime all over. There's something in there that we don't want, though. We don't want y prime, but do we know what y prime equals? Yeah, we take this, we plug it in there, and you end up with y double prime is equal to negative y plus x times negative x over y, all over what? Y squared, exactly. So now, can we just plug in the number? The point, I mean, yeah. Negative 3 plus, sorry, minus what? 16 over 3, all over what? 9? I don't like fractions. What am I going to multiply everything by? 3. Multiply everything by 3, and you get negative 9 minus 16 over 27, which is negative 25 over 27. And is that one of the answers? Yes. That just means find the second derivative.
And then
Key to this, be careful.
And then you just plug in the points.
Correct.